oh, go away. No. There. When we have two functions, one of them we will call f, the other one we will call g. The domain of A will be related to the domain of f, and the domain B is going to be related to g. So that's how we're going to differentiate. Okay, when we have a function that is created by putting them together, either we're going to add these functions or minus them, multiply them, divide them, then the way that we describe their domain is in the following way. If we have f plus g or f minus g, so if we are adding or subtracting them, then the domain is only the parts that overlap, right? If this is the domain of A and this is the domain of B, then only the parts that overlap apply to this new function. Let's call this new function h of x. H represents f plus g, then the domain of h is going to be the intersection of A and B. And we'll do a few examples in a second, okay? This also applies to if we are multiplying them together. Again, we have only the intersection points is going to be the domain of our new function h. Gets a little bit trickier when we divide, but hopefully not so tricky that we can't remember. The only additional restriction we have in the domain of h is that we want the intersection except anywhere where g is 0, because in this case g represents the denominator, and if we have a value that makes g 0, then we're dividing by 0, and then it's just boo boo boo. Okay, so again, this is h of x. So we're going to be combining different functions and trying to figure out what is the domain when we put these guys together. Okay, so here is an example. We have function f, which equals the square root of x. Can you tell me what is the domain of f, the square root function? What are our allowable values for the domain? Oops. What is x allowed to be? Greater than or equal to 0. Okay, now let's look at the function g. What restrictions do I have on g? Plus or minus 2, right? It's got to be somewhere in between there because it's 4 minus x squared. So we have to be between plus or minus 2. Okay, another way to think of this that sometimes helps if you're more of a visual person, let's sketch a number line. 0 in the middle. 1, 2, 3. And then backwards. 1, 2, 3. Okay, f says its restrictions are x has to be greater than 0. And for g, our restriction is it has to be between positive and negative 2. Right? So then when we are looking at adding or subtracting or multiplying, we are looking for only the intersection. So where do they overlap? Between 0 and 2, right? They only overlap between 0 and 2. So this is the domain of my new function when I add these two together. I'm going to zoom out so we can see the full picture there with the number line. Okay, another way that I can say this is using interval notation, where the square brackets represent numbers I can touch, and round brackets represent numbers I cannot touch. If I were to write, what is the function h, where h of x equals this? Well, it's square root x plus square root 4 minus x squared. So here's my new function and its new domain. Hopefully this is a bit straightforward, yes or no? Make sense? Okay, so let's look at B. My new function h of x is going to be square root x, because that's my f, minus, what is it, 4 minus x squared. What's my domain? It's the same, yeah. Oops, sorry. That was supposed to be a comma. Okay, that's straightforward. What's my domain here? Yes. No, just pick one that you're comfortable with. Absolutely. You pick whatever notation it works for you. I'm just showing you all the different ways. So I want you to pick what's comfortable and what makes sense for you. So again, based on our rules here, it's the intersection, so where they overlap, so it's still 0 to 2. Let's see if we can write what our function looks like. This is going to be root x times root 4 minus x squared. Can you guys simplify this? How would I be able to rewrite this? This is where your laws, exponent laws come in handy. Yes, ma'am. Yes. So because both of them are a square root, meaning they have the same kind of root, it's not a cube root and a square root, they're the same square root, I can just absorb that x in. So essentially what I did is I said x times 4 minus x squared. So either of those ways is fine. Okay. So we can identify the domain, we can identify the range, or sorry, the simplified version of this. Let's take a look at D. Here, h equals the square root of x over square root of 4 minus x squared. What is my domain? Talk amongst yourselves. Okay, can I get a volunteer to tell me what they think the domain is? Yes, sir? Uh-huh. Strict, okay, yeah, so you're saying this cannot be equal to 2, but it can approach 2, right? Or in interval notation, this would be can include 0, cannot include 2. Yeah. Okay, are we ready for the next example? All right, we can do this with the graph of f plus g. We can do this using graphical addition. So what we're going to do is we're going to graph some key points of f of x, which equals square root of x. What are some key points of a square root function? Shout them out. What are some key points? 1, 1, 0, 0. Give me one more. 4, 2. Okay, so that is my function there. And if I did g of x, which is the square root of 4 minus x squared, harder to pinpoint key points because this is not a function we're familiar with. So let's pick a couple of points. Let's say 0, 1, root 2. what would g of x equal if I put 0, 1, and root 2? If x is 0, g is 2. If x is 1, g is root 3. And then if it's root 2, and these are plus minus. Plus minus. Okay, so 0, 2, 1, root 3 is kind of here-ish. Root 2, kind of here-ish. This is essentially a circle. Yes. Because it's a circle. When we have a square minus a square inside of a square root, it represents a circle, right? Also, when we put the number in, right, the square root of 4 equals plus or minus 2. When we take the square root of a function, it could be two different things. Shouldn't be, say that again. Should be plus or minus 2. Plus or minus 2 here. Ah, yeah, sure. Yes. Because then we'd have a circle here. Okay, so then our h of x is going to be f plus g. We are taking the values that overlap. So between 0 and 2. Intersection point here, intersection point here. And I'm just estimating here, okay? I'm not doing any particular value addition, but I see that both of these are positive numbers. So the green will be a positive number also. Yes. Because it's in our domain. Between 0 and 2?
Yeah, but like
Okay, let me restart. So the block function is our f. 1, 1, 4, 2. Here it is, yeah? The red function is our g. Essentially, it's a circle with radius 2. Something like this, yeah? Where do they overlap on the graph? They overlap between 0 and 2. So my h function is between 0 and 2. The reason it's overlapping h at this point is because this is 2 on the pink and 0 on the black. 2 plus 0 is still 2. The reason it goes to here is because the black is a some number, but the red is 0. So a number plus 0 is the same number, right? So that's why these two are key points. They're the ends of our domain. And in between, I have a little bit of black and a little bit of pink, a little bit of black and a little bit of pink. So I just connect them in a positive number because it's going to be more than the pink and more than the black. We're combining those two positive terms. Okay, and this is not by any means a very accurate sketch. This is an estimation, but we're just showing that where they overlap is between 0 and 2. And it's going to be a positive function. Questions, comments, concerns there? Okay, let's flip the page. Composition of functions. This is where it gets a little bit on the trickier side. Composition of function is where we take one function and put it inside of another one. So two different ways that we can identify it. We use this open circle to identify a composition, or I will literally put g of x inside of f of x. Okay, we can simplify this, we can rewrite this, but in order to find the domain and ranges of this, we kind of have to sort it out. So in this example, I'm telling you that the function f is represented by x squared. The function g is represented by x minus 3. The first letter is the outside function. The second letter is the inside function. So this is outside, this is inside. So that means on the outside function, f of g of x, I am replacing x with the entire function g. So g is x minus 3, so this is x minus 3 all squared. So I've taken out the x and I have put in the function g. Can you tell me what is the domain of this function? Is there any restrictions on x? No. So this can go from negative infinity to positive infinity, or you can say x is all reals. Could you tell me the range of this function? Greater than 0. Okay, so in B, I now have the g function first and then the f function second, sorry. So that means I'm taking g of f of x. So I write my g function, it's something minus 3. Inside the something, I'm putting the entire function of f of x. So this is x squared minus 3. Okay, what's my domain? All reals. What's my range? Y is greater than negative 3. Right? Simple enough of an idea? Okay, so the idea is simple, and then now we're going to get more complicated. So now we're going to use the root functions again. Here is f, and here is g. So f of g means my f function is the square root, but instead of x, I am putting the entire function of g. So this is the square root of, oopsie, the square root of 2 minus x. Can we simplify this? Yes, sir. Yes, it would be the fourth root of 2 minus x. How did you get that? Power of a power, right? This is the same thing as saying 2 minus x to the power 1/2 all over to the power 1/2. Okay. Domain. This is an even root. Means we cannot have negatives on the inside of this root. So we need 2 minus x to be positive. less than 2. Okay, if we're ever unsure, here's how I do it. Everything under the root has to be greater than or equal to 0. So if I move the x over, I add x to both sides. This tells me that x has to be less than or equal to 2. Another way to write this is x can go to negative infinity, but can only come up to 2. All right, same idea here. Let's take a look at part B. Now we're starting with the g function. So big square root 2 minus, instead of x, I'm putting the entire function f. So this is root x. Okay, this one is complicated because we have a double root that we can't combine into one thing. We're going to use the same strategy. 2 minus root x must be greater than or equal to 0. I'm going to add root x to both sides. Yes, sir. Yes. How did you get there? So yeah, we squared both sides, right? Yeah. Perfect. Okay, so this is our domain. In other words, again, from negative infinity up until and including positive 4. Okay, f of f, the square root of the square root of x. So this is the 4th root of x. Greater than or equal to 0. So from infinity to 0 inclusive. Okay, g of g. This one's going to be a little bit ugly. Square root 2 minus square root 2 minus x. Okay, so I'm going to do some inequality math again, right? 2 minus root 2 minus x must be greater than or equal to 0. Add stuff to both sides to move that over. Square it. What's my next move? Move the x over to the right for plus x greater than or equal to 2 minus 4 negative 2. Okay, before I write that, does it make sense? Okay, pick a large number. 3. That's greater than negative 2. Would 3 work? No. Always check your math.
Oh,
Why wouldn't it work?
because
We just found the domain of the large square roots, but there is a smaller square root at play here. We have another restriction. If I focus on just the little bit here, 2 minus x has to be greater than or equal to 0. 2 must be greater than or equal to x. We have a double restriction here. What's my domain? Inclusive 2 to 2. Perfect. Okay,